Hi guys, and welcome back to Matthew Wooster. Today we're going to be talking about assigning oxidation numbers in chemistry. To start off, let me just remind you what oxidation numbers are. Oxidation states or numbers show how many electrons an atom loses or gains when it breaks or forms ionic bonds. It's used to track electrons in a redox reaction and determine what's being oxidized or reduced. So the main point here is how many electrons are being lost or gained, which is the same thing as being oxidized or reduced. And yeah, it's just used to track electrons in a redox reaction. So these are just the rules, and here is a table that you can find in your reference table. And we're just going to be doing 3 practice problems on how to determine oxidation numbers or how to assign them. So to start off, determine the oxidation state of sulfur and oxygen and sulfur dioxide. So the first thing we want to do is break this up. So we have sulfur and we have oxygen. Now, the first rule that should come to mind is rule number 7. Oxygen is almost always -2 when found in a compound. Now, sulfur dioxide is a compound, so this applies. So if we break it down even more, we have oxygen. We're going to replace the O with the -2 because it says oxygen is almost always -2. But we can't forget the 2. Now, that 2 is going to become a coefficient until we're going to multiply. And we're going to add it to whatever sulfur is, right? And it's going to be equal to 0. Why? Because, again, this is a compound. And here it says all chemical compounds except polyatomic ions are electrically neutral. So it's going to be equal to 0. So if we simplify this even more, we have 2 times -2, which is a -4. So S plus -4, or you can also just say S minus 4 equals 0. And that would just be 4, because 4 minus 4 is 0. It cancels us out. Because if we have a -4, we can cancel it out with a +4. Therefore, the oxidation state of sulfur is going to be +4, and oxygen is going to be -4. And that's going to be the oxidation states. Now, for the next problem, it says determine the oxidation state of nitrogen in the ammonium ion NH4+. So this one is slightly different from the first problem. Here, we're dealing with an ion, specifically a polyatomic ion, so it has multiple atoms in this ion. So we're just going to write this down, NH4+. If we break this down, we have NH4+. Now, if we look at our table up here, selected ions forming aqueous solutions, we can see that NH4+, which is ammonium right here, has a net charge of +1 because all of these have an invisible 1 attached. So we're going to actually set this equal to +1. Rule 4 says in a polyatomic ion, the sum of its atoms' charges has a net charge, and that net charge is 1. So it's going to be equal to 1. So if we break this down, we have nitrogen and we have hydrogen, specifically for hydrogen, and it's equal to 1. So if you look at our rules again, it says that hydrogen is almost always +1 when found in a compound, meaning H is going to be 1. So it's going to be rewritten as 1, and our coefficient will be 4, plus whatever n is, will be equal to 1. So now here, so we're going to have n plus 4 equals 1. We can subtract 4 on both sides to isolate the n, and we're going to be left with n is equal to 1 minus 4, which is -3. So the oxidation state of nitrogen in the ammonium ion is going to be -3. So n -3. Now for the third problem. Determine the oxidation state of carbon in sodium carbonate, Na2CO3. So in this problem, we're going to split it up again. So we have Na, 2 of them, then we have C, and then we have O, 3 O's. So the first thing that we see is Na, which is actually a group 1 metal. And in the rule over here, rule 6, group 1 metals are always +1. So we can replace Na with a 1, and the coefficient will be 2. And then we add with carbon. Now, it's asking us to solve for carbon, so we don't know what carbon is, so we can leave it as C for now. Then we add it to oxygen. And according to rule 7, oxygen is almost always -2 when found in a compound. So we're going to replace oxygen with the -2. And since there's 3 of them, we're going to have a coefficient of 3. So if we simplify this, we have 2 plus C plus, or actually minus 6. And we simplify this even more, we basically have C minus 4. But what is it equal to? It's going to be equal to 0 because this is a chemical compound. Then again, we can add 4 on both sides and we get C is equal to 4. Therefore, the oxidation state of carbon is going to be C plus 4.